Assalamu alaikum. We will present the Biot experiment, the circular conductor, which study the relationship between the magnetic field and the current. Also, the relationship between magnetic field and the radius of the loop and the distance from the loop. And the goals of this experiment are, first of all, determine the magnetic field of the circular conductor as a function of the current. Second one, determine the magnetic field of the circular conductor as a function of the radius of the loop and the distance from the loop.
The material used in this experiment are a set of current conductors with a different number of turns, also the different radius of loop, and a Tesla meter. This is called the B-probe, axial B-probe. This is the Hall sensor. This is high current power supply. This is the Biot law, which is the magnetic field, and this is mu, which is the permeability of a free space, and this is the constant quantity, and this is the current, this is the radius, and this is also the radius, and this is the distance from the center to the loop. Okay? We want to study the relationship between the current and the magnetic field. So we must put the Hall sensor at the center of the current. This is the Hall sensor, put it in the center of the loop. So we make the current at 15 ampere, make it constant, and make the B-probe forward to the center of the loop until the magnetic field reach the higher value. So the higher value is 26 Tesla. The Hall sensor at the center. So the current at 0 ampere and the magnetic field is also 0. When we increase the current to 2 ampere, the magnetic field will increase also at 5 degrees and increase the current again until 4 ampere. So the magnetic field will increase until 8. Okay, again increase the current until 6 ampere. The magnetic field will increase until 12. The last one, increase the current until 8 ampere. The magnetic field also increase.
This is a table show the relationship between current and the magnetic field, and we make this value constant. And the relationship between B and I is directly proportional.
So now we want to study the relationship between the radius of the loop and the magnetic field. So we put the current at 15 ampere make it constant, and the Hall sensor at the center of the loop. The same way we did before. So the magnetic field is 16 at radius 6 centimeter. The radius of this loop 6 centimeter. So this is the radius of the last step is 6 centimeter. Change it to 4 centimeter. So we change the radius and the magnetic field will increase. Now we are trying the loop of 3 centimeter. This is the last one. We change it to 3 centimeter. The loop becomes smaller and the magnetic field become greater. This is the last one. Is for 2 centimeter. So the magnetic field is higher than before.
This is the table show the relation between radius and the magnetic field, and we make this variable constant, and the relation between B and R inversely proportional.
Now we want to study the relation between the distance from the loop and the magnetic field. So we put the current at 14 ampere and the Hall sensor at the center of the loop, and we want to go 2 centimeter from the loop. This is 4 centimeter, and this is 4 centimeter. The magnetic field increase. Now we want to study the relation to the background of the center. This is 2 centimeter from the center, and this is 4 centimeter from the center.
This is the relation between distance from the loop and the magnetic field, and we make the current and the radius constant, and the relation between B and X is inversely proportional.
Professor Jamal suggested us to add letter N here. Letter N here, which is the number of turns. This is the number of turns. This is number of turns. This is 1, and this is 2, and this is 3. So we want to try the first one, which is the number of turns 1. So we put the Hall sensor at the center of the loop, and the current and 10 amperes, make it constant. And we want to, this is the magnetic field, which is 13. So we switch the power supply off and change the number of turns to 2. This is 2. This is 2. Switch on. So we notice that the magnetic field increased. So with the number of turns 2, the magnetic field increased. So we will try the third one, switch the power supply off and change the number of turns to 3. This is 3 number of turns. Make the Hall sensor at the center of the loop. So switch on. We notice that the number of the magnetic field increased.
As we know, this is the table show the relation between number of turn and the magnetic field, and we make the current 10 ampere and X equals 0, and the radius of the loop equal 4, and the relation between B and N
directly proportional.
We are surrounding with a lot of harmful field, like the magnetic field from the mobile. And this is the magnetic field in background without mobile, and this is the magnetic field with mobile. It will increase, and let's try to avoid using of mobile.